Why can light act like a wave in one experiment, but behave like tiny particles in another? Why do electrons sometimes move like bullets and sometimes like ripples in water? And how did one strange experiment force scientists to rewrite the entire rulebook of physics? Welcome to modern physics, the part where nature stops behaving normally. Take a dim flashlight and shine it on a metal spoon. Nothing happens. Now imagine shining a bright UV light instead. Suddenly, electrons can jump off the metal. It's not the brightness that matters, it's the type of light. That mystery launched modern physics. This is the Learning Studio, turning mind-bending ideas into simple ones. The first big shock came from the photoelectric effect. When light hits a metal surface, it can knock electrons out. But here's the strange part. A bright red light does nothing. A weak ultraviolet light instantly ejects electrons. So brightness doesn't matter. Frequency does. Einstein explained this by saying light isn't just a wave. It also comes in tiny packets called photons. Each photon carries a specific chunk of energy. Low-frequency photons, like red light, don't have enough energy to free electrons, but high-frequency photons, like UV, do, even if the light is very dim. This was the first proof that light is both a wave and a particle. But the weirdness doesn't stop there. Matter itself also shows this dual personality. When electrons pass through two tiny slits, they create a wave-like interference pattern, even if you send them one at a time. But if you try to measure which slit they go through, the pattern disappears, and they start behaving like particles. It's as if particles decide how to act depending on whether you're watching. This is the wave-particle duality of matter and radiation. Light is both wave and particle. Electrons are both wave and particle, and the universe at small scales refuses to fit into simple categories. These discoveries built modern technology. Lasers rely on quantum behavior of electrons, semiconductors and microchips depend on quantum energy levels, LEDs emit photons with precise energies, solar cells use the photoelectric effect, and even MRI machines depend on quantum spin. Modern physics doesn't just explain the strange. It powers your phone, your computer, your internet, your medical scans, your LEDs, your GPS, and everything electronic. And here's the real curiosity. If matter and light behave like both waves and particles, what exactly is an electron? Is it a point, a cloud, a probability? Modern physics answers that next, and the answer is even stranger than this.